Okay, we're just going to do two further examples on distance formula here. So let's have a look at this question. Find the exact values of a if the distance between 2 comma a and 4 comma 9 is 5. Okay, so what's different about this question is that they, rather than finding the distance, they tell us the distance, and instead we're going to find one of the values there. Okay, so let's call this. I'm going to call this point here x2, y2, and I'm going to call this point x1, y1. And the reason why I called, it'll become apparent a bit later on why I called this one point 2. It doesn't actually matter, but slightly easier if you call with the one that with the unknown that you're trying to find, point 2, slightly easier. Okay, so let's write down our distance formula. D equals square root x2 minus x1 all squared plus y2 minus y1 all squared. Okay, let's substitute in. The distance is 5. The x2 is 2 minus the x1 is 4 all squared plus the y2 is a minus the y1, which is 9 all squared. So the main reason why I made the unknown 0.2 was just so that it would appear positive in this term here rather than at the back with a minus sign. Okay, that's why I did that. Alright, so now the aim of the game is to solve for a. So the first step we're going to do is we're just going to square both sides of the equation and simplify this term here. That becomes negative 2 all squared, which is going to become 4. Okay, now something that might surprise you is I'm not going to expand this perfect square here. I'm going to leave that. You'll see why in a moment. Because the fact that it's factorized is nice. Minus 4 from both sides. And now all we've got to do is take the plus minus root. So a take away 9 equal plus minus root 21. So a is going to be 9 plus minus 21. Notice the question said values of a. There's more than one value. There's two values. Okay. If you're wondering why there's two values, I'll show you very quickly over here. So I've plotted the point 4 comma 9, and I've plotted. We know that the x value here of the other point must be 2. So I've plotted x equal to 2. And we're trying to find what y value such that the distance between this point and essentially this line has to be 5. This distance between 4 and 2 here, if it was horizontal, would be 2. So we're going to have to go up like this and find a 5 here. But also convince yourself that by symmetry you can also go down and find another 5 down there. Okay, so it kind of makes sense that it's symmetrical about this height of 9 plus minus this root 21. Okay, so that's why there are two particular answers here. So this point here would be 2 comma 9 plus root 21, and this point here would represent 2 comma 9 minus root 21. Okay, so hopefully I've convinced you why there's two answers and why that's okay visually. Alright, let's do one more question. This is a geometry-based question. You see some of these. Prove that the points A, B, and C form an equilateral triangle. The main thing is if they form an equilateral triangle, the lengths of the sides should all be the same. So basically, the distance from A to B should equal to the distance from B to C equal to the distance, and we're picking another pair A to C. Okay, that's 3 sides equal. So that's what I need to show, I should probably say. So I need to show. Okay. So basically we're going to be using the distance formula 3 times. Okay. I'm going to be this use of subscript is often used as well for when we're looking at particular sides. Okay, so let's just start off with distance of A to B. Okay. So square root. I'm going to jump straight in. Okay, so x2 minus x1, that'll be negative 1 minus 1 all squared plus y2 minus y1, 1 minus negative 1 all squared. Okay, convince yourself that that's square root of negative 2 squared plus, that'll be 2 squared, so that's 4 plus 4, which is root 8. Okay, which is 2 root 2 if you simplify the third. Okay, so that's the distance between A and B. Now let's work out the distance between B and C. Okay, square root x2 minus x1. Here C will represent 0.2 and B will represent 0.1. So it's minus root 3 minus negative 1 all squared plus, and then this guy, which is minus root 3 minus y1, which is 1 all squared. This guy minus this guy all squared. Okay, let's simplify a little bit. This term here is going to be, minusing a negative makes it a plus, right? So that's going to be 1 minus root 3 all squared. And then I've just got this term here as is. Okay. Okay, now it's going to be helpful to know the expansion of a plus b all squared is squaring the first, twice the product, and then square the last. So I'm going to use that formula to expand. Okay, squaring this guy, negative root 3 all squared. If you square a negative, it becomes positive. Squaring root 3 becomes 3. The product here, negative times negative makes positive root 3, so doubling the product will be twice the product of root 3. And then squaring the last guy, if you square negative 1 all squared is 1. Okay, let's I'll expand this guy as well using the same rule. Square the first, twicing the product, so we're going to minus twice root 3, and then squaring the last guy, if you square root 3, that becomes 3. Okay, so convince yourself that cancels with that, and what we've got left is 4 plus 4, which is root 8, which is 2 root 2. Okay, so good, we've got them equaling. And the last pairing would be the distance of AC. Okay. Alright, so let's do this one. x2 minus x1. So that's going to be bracket negative root 3 minus 1 all squared plus bracket y2 minus y1, so negative root 3 minus negative 1 all squared. And if you're clever, you can see that this line here that I've starred is precisely the same as this. Okay, so I'm just going to be a bit lazy here and go that equals to the distance of BC from star. Okay, which equals to 2 root 2. So therefore, noticing that it was in the exact same form, just these two terms switched. That's the only thing that's different, but that's not going to make a difference to the answer. So noticing that they're equal, I can just as long as I acknowledge it, that they're both in the same form, therefore they're going to be equal. Okay, just save a bit of time. So therefore, distance of AB equals to distance of BC equals to distance of AC. Therefore, ABC form an equilateral triangle. Alright, what I'd like you to do is work on the Mathscape 14.1. Make sure when you get to question 4, you only do the last column. Don't go nuts and do all of it. It'll take too long. Okay, today, general formula. Everything on one side equal to 0. No fractions. Coefficient of x positive. No common factor. The midpoint formula. x1 plus x2 on 2 divide a comma y1 plus y2 on 2, and the distance formula, which I'll just show you. Okay. One thing I should say though, these formulas for midpoint formula and distance formula you should memorize. So maybe make a note in your notes to memorize both of them. Alright, homework over the weekend will be to finish off everything from today, plus everything from last lesson, including the Mathscape 14.1. Okay, see you next week.